My name is Alex Williams, founder of the New Stack, and you're listening to the New Stack Analyst Podcast, a show about application development and management at scale. Thanks for joining us. The New Stack thanks Chef at Alcide for sponsoring our Pancake Breakfast at Kubecon plus Cloud Native Con in Austin, Texas. Learn more about Chef and Habitat, the simple, flexible way to build, deploy, and manage cloud-native applications at chef.io. And also a thanks to Alcide, an adaptive cloud-native security platform that you can learn more about at alcide.io. That's ALCIDE.io. Well, thank you for joining us this morning. Our discussion today is really about evolving patterns in Kubernetes and looking at, from this perspective on how really distributed applications and microservices are really changing the way we're thinking about how we really deploy and manage applications. And we're looking in many respects from a container perspective. I want to first thank Alcide and Chef for sponsoring this breakfast. Give them a big hand, please. This is really nice of them to support this. And this is our last Pancake Breakfast of the year, and we're really excited. This is a really interesting conversation. This conference is just outstanding, and just so much happening now. And we heard yesterday a lot about service mesh technologies, which I think we'll see that service in today's discussion. I want to start just if everyone could just introduce themselves on the stage. Why don't we go? Why don't we start here, and then we'll just go down the line.
Hi, I'm Erica. I'm an engineer at CoreOS.
Hey, I'm Tasha, and I'm the product manager for Habitat, which is an open source project at Chef.
Hey everyone, my name is Gadi Naor, and I'm the CTO and co-founder at Alcide, so I stand correct you, Alex. Sorry about that.
What did I do?
Just a name.
Okay, sorry.
If you're going to say sorry for the name, it's fine. Hey, I'm JJ. I used to work at Twitter before. I was a software engineer, built their cloud infrastructure management team, and built that. Thanks.
Great. Okay, so the Kubernetes. Well, before I get started there, I want to just say, here's the deal, everyone. We really make these Pancake Breakfasts an opportunity for you to ask questions, and to incent you to ask those questions, we will give you 5 extra raffle tickets for the big prize, and the big prize is an Arduino starter kit. Ask your questions. We'll give you more tickets, and we'll make this a real fun way to get some conversation going. I want to I do this every Pancake Breakfast. Can you raise your hand if you're a developer in the crowd? How many people would consider themselves operations? And how many would consider them both? So we have more people who consider themselves both, and primarily developers. Okay, how many would consider themselves? How many are engineers here? Software engineers. Okay, so that really says it all, right? Gadi, I wanted to ask you a first question. You wrote a really good post in the New Stack about what you were expecting here, right, at this conference, and you really focused on these evolving patterns, and you looked at such issues as, Kubernetes. You looked at microservices, right? And one of the things you talked about was service mesh as well, right? Now that you're here, and you've had a chance to talk to a lot of people, what are some of the themes you're starting to see in context with this idea of evolving patterns?
So first off, I think that right here at Kubecon, it was very interesting to see the hype on service mesh, and for many good reasons, we moved into microservices simply to enable teams to work in parallel. It makes a lot of sense that we move in parallel and deploy continuously into production, but it brings in a lot of complexities, mainly around we became pretty much the happy owners of the infrastructure. So operating Kubernetes is not trivial. Scaling different microservices is not trivial. And I think what Service Mesh comes to the rescue is actually simplify a lot of those aspects of how do I scale different microservices? How do I extract telemetry? I mean, each and everyone in the room that deploys Kubernetes know how hard it is to kind of troubleshoot what is happening between, a transaction that traverses multiple microservices. And we at Alcide, we focus on the security side of that, and that even, multiply the level of complexity. So definitely think that here we see kind of the evolution of microservices and how you operate them at scale, all the custom metrics. So it's very interesting to see that from Kubecon last year, how that kind of the conversation evolved.
Gadi, could you just tell everyone here a little bit about Alcide? And I like the story behind the name as well, so maybe you could tell that.
I'll definitely give the color on that. So Alcide, that's the French version of Alcide or Italian. It's the least known name of Hercules. This is why you can see that funny image on my T-shirt. But Hercules, when he passed away, he became the gatekeeper of the Olympus, and part of his job description was basically to avert all evil. In our prism, data center, cloud operation, this is enterprise Olympus today. I mean, this is where all your crown jewels are basically being kept. So this is kind of the shoes that we are trying to get into, simplify the complexities around operating securely those environments.
Great, great. So Tasha, I'd like to turn the attention to you just for a minute. And tell us a little bit about yourself. What is your role at Chef?
Yeah, sure. So I'm the product manager for our next generation application automation framework, which is called Habitat.
Okay. And so how do you see Habitat fitting into these evolving patterns that we're starting to see emerge? It seems like we've lived in a world of real an infrastructure-dominated world. Now we're moving more to an application-oriented world. And how does Habitat play in that?
Yeah, for sure. So when you start to think about all of the incredibly powerful tools that we're having out there, Kubernetes, service mesh, and then how we want to coordinate all of those to get microservices and variously complex workloads working across different infrastructures. What gets lost a little bit is what were you trying to do in the first place? And what we were trying to do in the first place is manage an application that brings business value to us. So what Habitat does is seek to harness all of that very powerful automation in service of our application and say, what is my application trying to do? Break that into meaningful services and building blocks, and then allow you to deploy that using Kubernetes, using the service mesh.
So Erica, you work at CoreOS. You're an engineer there. And what projects are you working specifically on?
I've been working on the open cloud services integration with our Kubernetes platform, Tectonic.
Open cloud services. So,
Yeah.
When you talk about open cloud services, talking about how the services integrate with CoreOS?
It's mostly about how you integrate services, I guess,
Right.
maybe, in easily like click button kind of automating the operations for a lot of operators and the applications.
How do you view evolving patterns that we're starting to see? What are some of the challenges that you're facing in your day-to-day work as you're trying to think through the complexities that come with Kubernetes, and kind of these various issues such as security, and other matters? And you guys are really focused on security as a company, so I'm curious in your perspectives there.
On security in particular, or?
Yeah, container security in terms of Kubernetes.
In terms in the application layer.
And what are you seeing as evolving patterns there?
Okay.
Sorry.
No. At the application level, you do see faster, smaller bits that can get deployed faster and faster. And that actually can really be very powerful in helping security because it keeps things up to date. It gets patches out faster, et cetera. And you're not kind of like tied to some sort of whatever version or something you're running on. We also, then can actually isolate each kind of functionality and try to dynamically watch and see what's going on, monitor that. And I think that helps bring us to a more secure place. There's a lot of work to do. Kubernetes makes some assumptions that you know, that the CIOs don't like, but I think we are moving into a world where if you can't stop developers from moving fast, I think, at this point. And it's about making sure that they have the right tools and the right kind of observability to make sure it's secure and up to date and everything.
JJ, you worked at Twitter as an engineer, and I'm curious, you know, and you have an area of expertise in, you know, kind of in terms of security. And tell us a little bit about the projects that you've been working on, and how do you see reflected in kind of what we're seeing in the Kubernetes ecosystem?
Sure. So Twitter started Mesos. I don't know how many of you know, but
yeah.
It was like pre-Kubernetes stuff, and then we Twitter open sourced, and it was like one of the first few companies to move from monolithic to microservices, and then we had like breaking down of monoliths to microservices problem. We had to wrangle with it at scale to get to know what is a microservice. So there's a lot of learning and a lot of parallels that I see in terms of how we went through that and where Kubernetes is and what Kubernetes is evolving to. Of course, there are technological differences between a two-level scheduler versus single scheduler types Kubernetes things. But essentially, like what others were saying, the abstraction of logging, monitoring, tracing, and then abstraction of security-related functions, and abstraction of CI/CD to give continuous delivery, that becomes like the core set of problems that you'd have to take away from developers and then help automate that and then let developers do microservices. Right? That eventually, that's going to be your problem when you have thousands of microservices by several thousand people getting done at scale on every single day.
Mm-hmm. So, does anyone have a first question that they'd love to ask right now? That we have one in the back over here, and then and I think Job has a question too.
So two of the patterns that I'm aware of right now are like the controller pattern and the operator pattern. So I was hoping to get some insight into like when should you use either pattern for like workflows in your organization. One of the workflows that we're working through is like cluster lifecycle. So should we be using like a resource definition in Kubernetes to manage Kubernetes? And then the other question related to that is like, if I'm testing both of those patterns, like what tools are available? Are there like patterns for testing controllers or patterns for testing operators? And maybe a little more specific, when I say operator pattern, I mean something that uses like the Go APIs in Kubernetes, but maybe has more complex lifecycle around the resources that it manages, rather than controllers, which might just like see something and create something somewhere else.
Anyone?
So, I mean, we use internally operator patterns. At the end of the day, each microservice has kind of its own characteristic, and it kind of composes a big application or even an internal application that exposes interfaces to different applications within the service that you're building. And the way that we approached it is basically building the brains into the different microservices and then composing them together into kind of how the whole application should pretty much go through the life cycle. So scaling internally the different microservices and upgrading. And sometimes, you know, if we change data models, then you need to actually code some data migration patterns into data persistency layer. So that's where we are challenged around that. Obviously, when you have like thousands of microservices, so this is something that amplifies in terms of, you know, testing it and making sure that the software is running, you know, pretty much 100% autonomous.
Erica? Oh, I'm sorry. Erica, I think I was going to ask a question.
Yeah, I think we're seeing a pattern where operators give you a way to sort of bundle the operations with the application itself. So kind of in the same way that containers, but at that next level, including the whole things like migrations or, if you need to have a backup or whatever it is, and that kind of automation, and bundling it together in one way. I think you're going to see even more of that kind of pattern, and then tools hopefully evolving to help you not have to write it from scratch every single time.
Yeah, and that's exactly what we're doing with Habitat too. So for Habitat, we have the Habitat operator for Kubernetes. And the idea there is that I should have information associated with my application live closer to my application, and that is going to be specific and tailored to each application. So let's kind of keep those in the same place as part of the same life cycle instead of trying to abstract it to a higher level.
Joe?
Yeah, I wanted to follow up with that question. Maybe could you expand a little bit more about how does Habitat work with Kubernetes? Is it just the Habitat's more on the build side and you're shipping the containers over to be run by Kubernetes? Or just explain that topology, I guess.
Yeah, absolutely. So with Habitat, we have a build, run, and manage your application over its life cycle. Kubernetes is an amazing way to abstract your management of infrastructure. You have container deployments, you have container management. I'm shipping my container out there. What Habitat does for you when you're using Kubernetes is it says, okay, what does my application need over its life cycle? How am I building it? How am I maintaining that build? How am I keeping it up to date as underlying dependencies and libraries are changing? And so we're doing that rebuild. We're allowing you to subscribe your build artifact to the upstream upstream open source packages that you depend upon. Automate the rebuild of that every time one of those upstream dependencies change, every time your application code changes. And then we're giving you a workflow to deliver that to your running Kubernetes clusters. And the way that we're doing that is we're providing both the Habitat operator for Kubernetes and then an automated way to take your artifacts and export them into a container that has your Kubernetes manifest that you can then deploy to your clusters.
Questions? We have one over here. And in the meantime, I actually have a quick question. I keep thinking about how this affects the organization and how the engineering organization manages itself, you know, as we start to move from these infrastructure to application-oriented environments. And, you know, this term came up of the operator, right? You know, who is this operator and how do they fit into the organization?
Well, I guess we don't have an operator anymore. Or
Is it an SRE then?
I didn't work at Google, so I'll let someone else speak for exactly if it would
But
be an
from your point of
SRE
view,
or
yeah,
whoever
yeah.
else. Yeah, I mean, there could be a world where maybe it is a self-hosted kind of concepts, and we don't need to separate the idea of having someone specific running versus developing.
Yeah, and so what we're really seeing is like this modern application team, which is where the application team is often responsible for developing and maintaining their service over their lifetime. You can see a lot of talks at Netflix about sort of that model, and like when I ship something, I'm still responsible for its uptime and for being on call if something goes wrong. In the enterprise, we still see a lot of developers handing things off to operations and needing to have a contract between those two groups. And so with that, you really have to make sure that if I, as a developer, am maintaining my application and then giving it to another team that may not have a lot of information about how to run it, how do we maintain the relationships between those two groups? So I think we see both patterns, but the modern application team where you're really responsible for your own services is starting to take over.
Gadi?
So I mean, it definitely kind of resonates with how we see this shift, and when you think about it, the developers that work on microservices, they normally have the application know-how, the context, like which other microservices they consume. So the way we think this should evolve is basically also to kind of factor in the knowledge and know-how of security, because at the end of the day, developers basically build the microservices, ops would operate that and deploy it into the production, and then you don't want to have your security teams or the CISO kind of not sleeping at night because things were left kind of unmanaged or unhandled. And while we are moving into application kind of centric infrastructure, you don't leave out the infrastructure itself. So at the end of the day, you want to layer kind of the infrastructure operator from a security standpoint, but also bring that application awareness into the different microservices. And this is kind of help you to scale, not only by delivering microservices, but also to keep it secure.
Yeah, I think it's very scary for a lot of people to move to a microservice, this quick deploying all the time kind of world. You don't get to kind of check every little thing and make sure it's right or what you think is right. And that's really scary. I think it's scary for people who are traditionally operators, for developers. You kind of lose some of the, I can just SSH into this machine and figure out what's going on kind of thing. And giving up that control it's a very scary thing to do. And the way kind of to get around that, right, is by building this whole platform, this whole like life cycle of the application from one point to the other, you know, kind of more so buzzwordy, but continuous security, continuous compliance kind of thing.
So JJ, how did you approach this when you were, when you were at Twitter? Because those were earlier days when you were starting to see a scale that was just unprecedented, I think, online. And, and you had to really kind of think through this stuff and do things that had never been done before.
Yeah, so when Google faced that before Twitter did, but we, both in Twitter and Google, there's a SRE organization that's basically was responsible for the resiliency of the platform. But what the trend is towards creating a more resilient platform so developers can actually start working towards just delivering code. And code keeps getting delivered like every single day, and something gets broken. And the rate of severity, sev-zeros, from the beginning to the end was like a lot less. Like towards the end, we had like a lot less sev-zeros. But then as we built the platform, as we broke the monolithic down to microservices, there are like multiple times the system will go down for like half a day and stuff, and then building that platform that's like highly resilient, like with mesos, with observability, with like key distribution mechanisms and all the things, abstracting that away and centralizing that and making that to be solid was a decent amount of effort, and that's still managed by SREs, while applications that are built, packaged, and then shipped to mesos are like automated heavily.
Okay, let's go with the question here.
So I heard a lot of discussion about security, and frankly, that's one of the things I kind of gloss over, because we're in our group, we're learning Kubernetes. We've been banging at it pretty hard here for the last 8 months or so, and frankly, I've kind of wanted to get the concepts down before I go deep into the security stuff. But the more I hear here, I start thinking, wow, we should start thinking about security now. But the pattern that I'm seeing is that when you're starting to rapid prototype things up very quickly, the microservice is very conducive to that, which is great. But what our developers want to do is they want to bang out the code, get the microservices going, get things talking to each other. And then when somebody says, oh, that might not be secure, these two shouldn't be talking to each other, they say, we'll do that later kind of thing. So you sort of like garner all this technical debt. And I guess my question to you is what advice do you have for that kind of pattern? Should we get the developers to just bang out the code, get everything working, and secure it later? I mean, is that going to be really hard, or should we start getting some of that security stuff up front in the development cycle?
Probably both. I mean, be careful. If you stop or try to cut off developers, they're probably just going to like build their own CI/CD platform, and that is definitely not going to be as secure anyway. So I think as a community, we are working towards helping get the tools and patterns and kind of things going, and keep up on the front with that and integrate it as much as possible. And at the same time, it's going to be a different kind of angle. You have to look at security.
Because the things I see with security, for example, are, let's say, the TLS authentication between microservices and such, which is great. But then that means somebody has to, or something has, or somebody has to write something or get something that manages all these certificates. You need a PKI infrastructure, you need revocation lists, you need all this infrastructure on top of our thing. And now it's like, do I have to modify the existing microservices, or can I just put these things somewhere on the side, just bolt it on like a little, just bolt it on over here, and developers are like, okay, cool, we got this little thing on the side. It's easy, I didn't have to do anything. I would love that, so that they can keep thinking how they're thinking, and we just kind of secure all the communications for them. Is there anything like that, or any patterns that are coming out to do those type of things?
Yeah, I mean, I think it kind of gets down to you have to get very good at rapid iteration across your application stack and across your services. And then you have to add the automation within there at the different layers, so at the networking layer, at the deployment layer, at the how am I updating my application code layer as different vulnerabilities are introduced by the software that I'm shipping. From an open source perspective, there are a bunch of tools you can check out. Chef has an open source tool called Inspec, which is a compliance tool, where basically depending on what industry you're in, you can say, these are the profiles I have to be in compliance with, and scan your infrastructure and see how each node is behaving and performing. I know there's a bunch of other stuff out there. So there is automation that you can leverage to try and start tackling these problems at a programmatic level.
Gadi?
So I think you're making a great point here. I mean, the first thing is that you want to have your microservices running because you're building some business logic, or so get that first up and running, get a taste of that. But once you think about security as a post-mortem kind of process, then you'll end up, dealing with a lot of technical depth, and security technical depth is something that eventually can end up as a breach or something that, neither of us want to deal with. So the way that we think about it, and not all companies that are sitting here and migrating are web scale companies that they have hundreds of engineers that basically build like infrastructure from scratch. Take the layered approach. I mean, you do some of the security mechanisms at the source level. I mean, with source scanners, you do the vulnerability scanning in your pipeline, and then this code is deployed into the production. Think about it as a layered approach, and TLS and secrets is everything that you need to manage. So, and if you're running on public cloud, for example, and migrating some of your workloads from virtual machine-based workloads into containers, then you end up with complexities about managing security groups inside, the public cloud. And if you even think about, doing multi-cloud, then you end up, pretty much making CISOs' nightmares into reality, because they end up managing many security tools, and this is the last thing that they want to actually deal with. So you want to think about it holistically, something that kind of deals with the challenges around both the kind of bare metal infrastructure or virtual machine infrastructure, and also take care of what is like the east-west policy between microservices. And then go to frameworks like service mesh, where you can actually authenticate and authorize different microservices at the application layer.
I was going to add, security and operations used to be a very high prohibitive costs for smaller organizations. One of the reasons like Kubernetes is taking off, I think, is because it gives you the tools to automate a lot of those kind of parts and scale with much better in close line without like having to have a whole team and everything. So that we have these problems is itself like a good sign, I think, of what now you have a smaller team can do the same amount of things.
Yeah, I was thinking about that just last night, like 1,500 active contributors to Kubernetes, right? And then how many people are focusing on your application code. So like just the fact that you have this incredibly engaged community that's looking at vulnerabilities, that's thinking about these questions, a lot of enterprises that have bought into these technologies and that are then actively looking at them, scanning, contributing back, like it puts us all in a much better place.
Just to add to that, sorry. To add to that question, I mean, developers are eventually going to ship insecure or software. That's given, right? So centralizing security is, whether you like it or not, is going to be must. There are standards like SPIFFE that came out of LOAS implementation within Google. And we had a similar implementation in Twitter, and there was a similar implementation like that in Netflix. So we tried standardizing around that to centralize the TLS and cert management and key distribution management as a problem there. You can check that out. And there are like standards that are trying and getting proposed for authorization as well. That will still run as a sidecar proxy.
Another kind of thing I was going to add with that is, when you have a very fast-moving organization, that means that you need to teach about security. You need to teach each other, and that's the only way you can scale people into your organization as well. Just wanted to make sure that we got that in there.
Great. Question. We have a question right here.
I was just going to add comment to that. The service mesh, STO in particular, they have this mixer that solves the centralized security problem where everything goes through them. You have policy management, security management, everything in one place. Isn't that the answer, or is there a better way?
So first off, you should ask yourself whether, from a performance standpoint, this is something that you are willing to live with in terms of, yes, we built an application layer kind of fabric that interconnects the different services. You get a lot of benefits of observability, but I would extend that observability not from the application monitoring standpoint, but also from a security standpoint. Do you get that security observability of whatever is happening inside? So you get for free, for example, MTLS within that fabric, which is awesome. I mean, I don't know how many of you bootstrapped like TLS between microservices by their hands. It's not easy to establish the trust chain and then manage the certificate rotation. So you get a lot of kind of hard-to-wire functionality out of the box. But at the end of the day, you need to have also understanding of what's happening the minute after that microservice was breached. I mean, you need to make sure your infrastructure is well covered, and it can be, distributed firewalls that goes far deep than, the simple network policies inside Kubernetes or even the public cloud, but also take a look of bring in more of the kind of traditional network security practice into those environments, but also make sure that you manage that complexity by engaging developers in, engaging ops team in, and having like multiple authors, deal with security just as much as they deal with building the service.
Question.
Yeah, I was just wondering, I liked your answer about the, building the security into the mesh, actually, but it brings up kind of the question I'm asking, which is, how close do you get Kubernetes to your developers? So are all your developers running Kubernetes on their laptops so that they can use the security model as part of their development process? Or do you have like a shared environment where they have their own Kubernetes cluster or in the cloud or something, and then they push to there when they're doing that? Or is there a multi-tenant environment, or is it part of the pipeline? How close are you getting to running Kubernetes now on everybody's laptops with all the policies down there and all the security layers built in and all of the infrastructure essentially at their fingertips?
So I can answer that all of the above, basically. So in the initial phase of the development, you kind of use your Minikube or your locally deployed cluster, and maybe you run part of the microservices and the rest of them are actually interacting with a cluster on a public cloud. So, I mean, we internally, for example, we have dozens of clusters that we employ on different public clouds. So not all the developers would deploy the full system into their laptop. I mean, it doesn't make sense. And they do want to test their software with all the security mechanics built into it. So for example, for us to just develop something that happens on the security agents that are running on the worker nodes, you have to run them inside a TLS and bootstrap those agents in test into the cluster that they're reporting to. So we have to do that. And then it gives you kind of the certainty and assurance that once you get into production, so you get to test it, the security functions that you built, right with your code and the business logic that you baked into microservices and whatever. So you have to start at dev to get on your feet in production?
I think it'd be great if every developer could have their own cluster, but that's very expensive. And I think you see there's a pattern where as you move to microservices, you know, once you could just run it on your laptop, then you have another dependency, and so now you need to make sure and have some kind of bash script or whatever to run that too. And then it gets more complicated, things change, and then you can't necessarily develop like that, not easily. And then I think that's where you see people move to almost everyone gets their own cluster kind of model. And that gets very expensive, and then you can try a shared one. Or we're also seeing like what started with Minikube, and I think the Tectonic Sandbox has been very successful as well of minifying and having when you need as much of the full experience as possible.
Yeah, I guess I kind of wonder how this is going to evolve from a developer perspective, because we've seen sort of entire technology shifts as we are like, you know, every developer is going to have to learn this, every developer is going to have to learn this. But at the end of the day, the developer's job is really to create new business value that just is in their application code. And having people, how do we make sure that when they're building that application code that it's secure and that they don't or do have, and that, like, where does their area of ownership end? So with the modern application team, what we see is that their area of ownership extends all the way out into production and that they're responsible for the lifetime of this service. With more traditional organizations, we see that it works on my machine and I'm handing it to ops now. And then how do we empower ops to actually have the tools they need to get this to run reliably?
Or it doesn't work on my machine, but actually works in production. More common these days, I think.
All right, we have time for one more question. We're in the back.
So I think we have had enough discussions about security. That's a common concern.
Never.
So just to change the topic a little bit, how are people or developers doing unit tests and integration tests in this environment where you have so many microservices and then you have dependencies and then one thing is not available, your code is dependent on it, it breaks. So how do you handle that complexity from the testing perspective?
For one, I think that probably has always been a problem, really. It's just that it's very visible now. It's made explicit. You see it in your infrastructure rather than just in code paths that are very difficult probably to follow, just as much as sometimes interdependencies between microservices. And so it makes it very explicit that you can't test everything and that you need to, just as best as possible, define your constraints, define what your interface is, and test at that level.
Yeah, so what we do with Habitat is we ask the application developer to tell us when they're writing their automation what services their application is dependent upon. And so when we ship that artifact, the application itself has been bundled with the information that I bind to this service. This is how I look for this service. And then you can empower the various services themselves to understand how to communicate between themselves, how to do leader election, and how to discover each other. So what we're trying to do is basically bundle the automation that every service needs with the artifact itself so that they can handle basic distributed systems problems as you deploy them across your infrastructure.
Yeah.
So, go ahead, JJ. I was
No. So, I mean, I was going to add to that. So one thing, to rephrase your question, I think it's more of a question of, in the world of microservices, what are the things that I need to be concerned about while developing microservices? Right? So a service that I can actually package, ship, and deploy, and what are my concerns in terms of that? So as it grows, typically what you'll find is like there are 3 types of isolations that needs to get that you get by going with microservices, which is security isolation, performance isolation, and then failure isolations. So when you can isolate those things into your microservices, then the tests and coverages around everything that you need to do needs to happen within that microservices. The one big tenet, like Amazon was a big advocate of it, where APIs never break. Right? So that's a core tenet that you'd have to follow so that you play well with the ecosystem of like how many or thousands of microservices that you have out there. So those are like few key things that as a developer you need to be concerned about, and you need to plan for it, you need to think about it and develop. You don't need to do the security yourself, but you need to understand that security is isolated within your code, if you know what I mean.
Great. Gadi, do you have a last thought?
So I can share from our, say, personal experience at Alcide, the way that testing is an art by itself. So we do the unit testing and try to do inside Docker Compose during the build time, kind of isolate a microservice and test some of the functionality there. But what we did to take it to the next level is actually adopted some of the testing framework, the internal testing framework of Kubernetes. So essentially, it's running part of the continuous kind of development, deployment, and staging clusters. And it's all automated. We have like Kubernetes chaos monkeys that basically kill different microservices, change, like scale in, scale out the replication level of the different microservices. Pretty much kind of try to shake the environment as much as we can and try to break it in order to kind of find like what would happen in production in real time. And I totally agree with JJ here that we're doing that on the performance dimension, security dimension, and functionality dimension, and try to kind of shake that. GitHub has like that test automation framework, and it's pretty powerful. So I definitely recommend to dive into the Kubernetes project GitHub. It's one of the folders there. It's hiding, but it's pretty powerful.
Great. Well, I want to thank all the panelists for your participation in this Pancake Breakfast today. Thank you very much. Let's give them a big hand. And I'd like to thank Alcide and Chef for sponsoring the Pancake Breakfast. We really appreciate it. And now it's time for the drawing. Okay, I guess we need to keep collecting some ticket stubs if you have them.
If you don't win the Arduino, we have some T-shirts here. So
T-shirts are over here
still
too.
Get something.
Great, I want one. All right. Okay, we're getting those.
Okay, the winning number is 461-889.
461-889. Hey, we got a winner. Thank you, everyone. Thank you for a great Pancake Breakfast. Have a great show. The New Stack thanks Chef and Alcide for sponsoring our Pancake Breakfast at Kubecon plus Cloud Native Con in Austin, Texas. Learn more about Chef and Habitat, the simple, flexible way to build, deploy, and manage cloud-native applications at chef.io. Alcide, an adaptive cloud-native security platform that you can learn more about at alcide.io. Listen to more episodes of the New Stack Analysts at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.